Hi everyone, welcome to lesson 17.1 about algebraic methods. And this lesson we're actually not going to do in your Springboard book, so I have attached a lesson 17.1 note sheet on Google Classroom. So if you have printing abilities, go ahead and do that. Otherwise, you can just follow along, but you're going to want a pen or a pencil and a calculator for sure. Okay. So the learning target for today is that we are going to determine the linear factors of polynomial functions using algebraic methods. So we did a lot of factoring in Unit 2, but it was all quadratic functions. So now we're also going to focus on polynomial functions, so different degree functions. Okay. So basically what we're going to be looking at is in class today we talked about the difference of squares, which is when you had two squared terms and you just took the square root of each one and then wrote it as plus and a minus, right? But now we're going to be looking at two cubed terms and we're going to look at the sum or difference. So over here, obviously, if there's addition, it's sum. If there's subtraction, it's difference. And what you're going to do is you're going to take the cube root of each term. Okay, so we're going to take the cube root, not the square root, the cube root. And if you don't know how to find that, what you're going to do on your calculator is go to the math button and down to number 4. That will give you the cube root button. Okay, so math number 4, you may want to jot yourself that little note for your calculator. Okay, so you're going to take the cube root. So cube root of a cubed would be a, cube root of b cubed would be b. And then you're going to plug into basically this form every time. Okay, and so you have just your a and just your b. Then you have your a value squared, your b value squared, and then your a times your b. Okay, so that's how you're going to fill in each of those. And then this phrase here helps us to figure out what the signs should look like. Okay, and we like to call this phrase SOAP. Okay, because that's what the first letter of each one represents. So the S stands for same, and that means that your first sign is always going to be the same as it was in the original problem. Okay, then the O stands for opposite. So that means that your second sign is going to be the opposite as it was in the original problem. And then the AP, that goes together, that stands for always positive, and that means that your third sign is going to always be positive or a plus sign. Okay, so just be careful with all of that. All right, so now let's go ahead. Let me erase some of this stuff here, and let's go ahead and try one. Okay, so part A, we have x cubed plus 125. So this would be a sum of cubes because we can take the cube root of x cubed and we can take the cube root of 125. So I'm going to go ahead and start out by doing that. Take the cube root, take the cube root. And first of all, cube root of x cubed is x. And cube root of 125 is 5. And if you don't know that off the top of your head, that's okay. Just make sure that you plug it into your calculator. So you would go to math down to number 4 for cube root and then 125, and you should get an answer of 5. Okay, and we will use a lot of the same numbers quite often. So like we know now, 5 cubed equals 125. 4 cubed equals 64. 3 cubed equals 27. And you guys will start to recognize these numbers pretty often, okay? Because you'll see them so often. Okay, so anyways, we get x and 5. And now what we need to do is, since this is actually a sum, we're going to be looking at this, but we need to make a set of parentheses here and a set of parentheses here. One needs to fit 2 terms and one needs to fit 3. Okay, so up first, all you do is you put in your x and you put in your 5, just like we got here. Okay, then in this first spot here, you need to square your a term or the x. So that would be x squared is just x squared. Then in this spot here, you need to square this term, the b term. So 5 squared is 25. And then in this spot here, whoops, you need to multiply them together, a times b. So x times 5 is 5x. Okay. Then to figure out our signs, we're going to use SOAP. So it was originally a plus sign. So we're going to do same in this first spot. So the same would be a plus sign. Opposite, so that would be a minus. And then always positive. That's our SOAP. And that's it. That's your answer right there. So as long as you can remember or you write down these two formulas, you should be good to go. And if you can remember your SOAP, same, opposite, always positive, then you should be good to go. Okay, so let's try another one here. All right, so first up, we have x cubed minus 8. So again, let's take the cube root of each. The cube root of x cubed is x. The cube root of 8 is 2. So 2 cubed is 8. So then we're going to go ahead and write a parenthesis, parenthesis. This one fits 2 terms. This one fits 3. Okay. In the first set of parentheses, you just write your a value and your b value. Then in the second set of parentheses, you square your a value in this first spot. You square your b value in the last spot. So 2 squared is 4. And then you multiply them together, a times b in the middle. So x times 2 is 2x. Then all we need to do is put in our signs. So we look at the original sign, which is a minus, same, opposite, always positive. And that's it. That's our answer. Okay. All right. So then if we go ahead and take a look at C, actually, first thing here, we still are factoring. This is a type of factoring. So you still always want to be looking if you can take out a GCF first. And in this case, we actually can. We can take out an 8. So if I take out an 8, then I'm left with x cubed minus 8. And we actually just did x cubed minus 8 here. So I'm going to write that exact same answer because it's going to work out the same way. But I'm going to put that 8 out front. So we know, okay, we took out a GCF in the beginning. So this would be your final answer. All right. So at this point, I'm going to have you guys pause the video and be careful with this next one. There is a term here that you're going to have to take the cube root of. Okay. And then I want you guys to pause the video and try to come up with this one. All right, awesome. So hopefully you paused and you were able to take the cube root of each of these. And cube root of 64 is 4. Cube root of x cubed is x. So that one would be 4x. And then cube root of 27 is 3. So I'm going to write this. We've got our our parentheses that fits 2 terms, parentheses that fits 3. And I'm going to write this as 4x and 3. Be careful here, 4x squared. So when we go to square this, you have to square both parts. So 4 squared is 16, and then x squared is x squared. Then you have your 3 squared is going to go here. So 3 squared is 9. And then in the middle goes 4x times 3, which would be 12x. So be careful with that one. And then just go ahead and look at your sign on the original, which was a plus. So we would do same, opposite, always positive. And that is your final answer. Okay, so that one was a little bit more tricky because we had a leading coefficient here. Awesome. So that is sum and difference of cubes. Okay. If you have any questions on that part, we will be talking about it during the Zoom tomorrow. Okay. Up next, we're going to move into higher degree polynomials. So obviously, we've now dealt with some cubed functions, but now what if we have an x to the 4th? Okay. So this is actually going to bring us back to our factoring of quadratics because we're going to use the x method. Okay. So remember with your x method, you put your a times your c value on top. So 1 times negative 12 is negative 12. And then your b value in the bottom, which is 1. And then you have to try to see what two numbers will multiply to give you negative 12 that add to give you 1. So that's going to be 4 and negative 3. Okay, 4 times negative 3 is negative 12. 4 plus negative 3 is 1. Now, the only difference is because this is an x to the fourth, we can no longer just say x plus 4 and x minus 3. Because if we were to FOIL or multiply this back out, we would only get an x squared. So what we need to do instead is put x squared times. So x squared plus 4 times x squared minus 3. Because now, if we were to FOIL or multiply this back out, we would do x squared times x squared and get x to the fourth. And then if you kept going here, you'd get negative 3x squared, positive 4x squared. So that would give you this positive x squared, and then the minus 12. So you would end up getting what we originally started with. Okay, so just be aware of that, that really all you're doing is changing how you write your factors because you need the x squared there. Okay, so this would be your answer here. All right, awesome. Let's try another one. You've got 1 times negative 20, so negative 20 here, and 1 here. So what two numbers multiply to give you negative 20 that add to give you 1? 5 and negative 4. So again, because of this x to the fourth, I'm going to write my answer as x squared plus 5 and x squared minus 4. Now, you have to be careful to check your final answer because I can tell here that this x squared minus 4 simplifies further. Okay, this is actually a difference of squares. So this is something that we learned in Unit 2. So we would go ahead and still write out this first one. That doesn't change. But then this difference of squares one, we can write as 2, because if we take the square root of each, we can write it as x plus 2, x minus 2. And that would be your final answer written in simplest form of your simplest factors. Okay, so you got to be careful. You've always got to check to see, okay, can this factor any further? Okay. All right, so then we go ahead and do part C here. And we should get 1 times 15, which is 15, and negative 8. Okay, so you are trying to think of what two numbers multiply to give you positive 15 that add to give you negative 8. And you should be looking at negative 5 and negative 3. So you look at this fourth term, or fourth degree, and you write it as x squared minus 5 and x squared minus 3. And neither of those 5 or 3 are perfect squares, so that would just be your final answer. Okay. Awesome. Okay, so again, I want you guys to pause the video and try part D on your own. Okay. All right, so part D, what two numbers multiply to 36 that add to negative 13? Okay, you should be getting negative 4 and a negative 9. And then when you write your answers, be very careful here. Both of these are actually difference of squares because 4 is a perfect square and so is 9. So now I'm going to write this as, if I take the square root of these, I can write it as x plus 2, x minus 2, And then same thing here. If I take the square root of both of these, I can write it as x plus 3, x minus 3. So this would actually be your final answer. Okay, so don't get tricked by that. Awesome. All right, very last thing we're going to talk about in today's video is going to be difference of two squares, again, when there's a higher degree, so when it's an x to the fourth. So again, when we're going to start out the same way, just like we did when if this was x squared minus 9, we would write it as x plus 3x minus 3, but now it's x to the fourth. So now we have to write it as x squared plus 3 and x squared minus 3. And that's it. That would be your final answer there. Okay. Again, you just have to be careful that none of your factors can be simplified further. Okay. So we would do the same thing here. Square root of 36 is 6. Square root of x to the fourth is x squared. And square root of 121 is 11. So we're going to write it as 6x squared plus 11 and 6x squared minus 11. All right, and that would be your final answer. Next one, we have 9x to the fourth minus 25. So square root of 9 is 3. Square root of x to the fourth is x squared. And square root of 25 is 5. So 3x squared plus 5, 3x squared minus 5. And again, last one, I want you guys to try here on your own. Be careful, you want to be checking if it simplifies any further. All right, so hopefully you pause the video, and when I go to take the square root of x to the fourth is x squared. Square root of 16 is 4. So I write this as x squared plus 4, x squared minus 4. Now, there is no sum of two squares, but there is a difference. Whoops. So we can simplify this further here, and I would rewrite this final answer because we would take the square root, so I would write it as x plus 2, x minus 2, and that would be your final answer there. Okay, so this is a lot of different types of factoring with higher degrees, so to x to the fourth and x to the third polynomials, third degree, fourth degree polynomials. If you have any questions on any of these methods, please bring them to class tomorrow and we will go over them during the Zoom. Thanks, have a good one.